Hey there everyone! Today we are going to be talking about the double slit experiment. Here's some initial important information for understanding the double slit experiment. When waves overlap, there are two things that can happen: constructive interference and destructive interference. If there are two peaks that overlap to make one big peak, or two troughs that overlap and make one big trough, that is called constructive interference. However, if there's one peak and one trough, they will cancel each other out. This is called destructive interference. Now let's say you have a machine that can shoot photons, particle by particle, and a speed of light, and a screen that has two slits in it. These slits are minuscule, as they have to be smaller than a wavelength, which would be about half a micrometer. One would expect that if firing electrons or photons through the two slits, you would get two clumps of final landing position. However, that is not true. If you fire photons one at a time through the two slits, you will get an interference pattern. At first, each one will send through like a particle with a really well-determined position and will hit a specific spot. But if you keep firing them, then the interference pattern will occur. It emerges in the final positions of many completely unrelated photons. This means that the particle knows the interference pattern of a pure wave that has passed through both slits equally and chooses its landing point based on that. All photons, electrons, atoms, and even molecules will do this. They will all travel through both slits as some sort of wave, which interacts with itself to produce an interference pattern, except the peaks of that pattern are regions where there's more chance the particle will land. It is a wave of possible undefined positions that at some point, for some reason, will resolve itself into a single certain position. The particle is like a particle at either end and a wave in between. The wave holds information about the possible final position of the particle, but also about its positions at every single stage. So, the wave must map out all of the possible paths the particle could take. The mathematical description of wave-like distribution properties is called the wave function, which was discovered by Erwin Schrödinger, who we will discuss later. Describing the behavior of the wave function is the heart of quantum physics. The double slit experiment leads us to one of the most important parts of quantum physics, which is wave-particle duality. A particle is both a particle and a wave at the same time for both light and matter, and the double slit experiment shows us this. That's it for today, guys. Thanks for watching.